So proportions is when we take two ratios or rates and we set them equal to each other. So we're going to be forming an equation here, and often what we'll be doing is solving for an unknown. It's like in the setup of this problem here, we can see we have this unknown value in this denominator. But it's where we have this kind of set rate. The idea is that if we change one of those numbers, in this case, like where we know 17 to 3 is our ratio, what if we change that 17 up to an 85? Then what would we need in that denominator to have the same ratio of 17 to 3? So we're just kind of bumping things up here, and we need to know what number needs to be in that denominator. Now there's a few ways to go about this, and if you have a way of solving proportions that you're used to, absolutely continue to use that. What I'm going to show is called cross multiplication, and it's just a nice trick to use with these, especially when your unknown values in the denominator. We'll go through an example where the values in the numerator, and then there's even a little simpler trick to that. So I'll be sure to describe that in our next example. But for these where it's in the denominator, what we do is called cross multiplication. So we have our equal sign, and what's important is that that stays put. So what I'm going to do is just drop down the equal sign. So that's going to stay right there. And then what we do is we go cross, numerator to denominator. So like that 17 and x, those are going to connect with each other. So those two are going to be a pair. And then another pair goes denominator to numerator. So that 3 and 85, and that's going to be a pair as well. Now what's going to happen is we're going to multiply those. So that 17 and x, that's a pair. We want to multiply those together, and they're going to go on one side of the equation. Now it doesn't matter which side. The key is that they just go on one side, and then the other multiplication, that 3 and 85, goes on the other side. So that's 17 times x. I'll go ahead and write that out here. 17 times x goes on one side, and then on the other side, we'll have the 3 times 85. So this is why it's called cross multiplication, is you end up making this cross here, and those that connect when they cross, you multiply together. And then we simplify. So 17 times x is just 17x equals 3 times 85, and if we use a calculator to help out, that'd be 255. And then it's a matter of solving for x. So I would divide both sides by 17 to get x all alone on one side of the equation, which should give us 15. And this is solving equations, so you could check your answer. So we could check, is 17 thirds, is that equal to 85 over 15? And we can use the calculator here. So if I type in 85 over 15, you can see I get this decimal out, which doesn't help me, although you could type in 17 thirds and see they're exactly the same in decimal form. That works great. What you can also use is this convert to fraction button. So 85 over 15 isn't simplified. So if you do this convert to fraction, there we can see our simplified form of the fraction with the 17 thirds. So those are in fact equal to each other. So it does work out here. All right, let's look at an example that deals with units. So what if we were dealing with rates? So in this case, we're dealing with a rate that's minutes to miles. And this is a case where our unknown is in the numerator. So there's two ways to go about this. If you like the cross multiplication, absolutely go for it. We can cross multiply. That works great. In fact, let's go ahead and do both ways. I'm going to show you two forms for the same route. Cross multiplication, some extra steps here, but it's not too bad. But just to get our practice. So cross multiplication means we'll multiply those together. So if I bring down my equal sign, on one side we'll have Q times 11 miles. And notice that our unknown does not have units on it. We're doing that on purpose. So The variable does not have units, but everything else does. So Q times 11 miles. And then on the other side, we'll have multiplication of 5.5 miles times 10.2 minutes. Ooh, that got a little squished there. I'm just going to move that over. Okay, so I want to solve for my variable. So there's my variable hanging out there. It's being multiplied by 11 miles. So what I want to do is divide 11 miles from both sides of the equation. And what that will do is my variable will just come down here, equals numerically, and I'll go ahead and write this out. We're going to take 5.5 times 10.2 divided by 11. Numerically, that's what we're going to calculate. So it's just a matter of grabbing the numbers and keeping the operations correct between them in terms of multiplication and division. Now the units, what we can see is we have miles in the numerator and denominator, and a key piece is that we have multiplication here, and that allows us to cancel. So miles is going to cancel out. When we divide those with each other, they just turn into a 1. So the only units we're left with are minutes. And this works out great in terms of the setup of the problem, because when we have these proportions, it should line up that the numerators and denominators have the same units. So those should both be minutes there, and these should both be miles. So for Q to end up with units of minutes is perfect. So that's working out just as it should. And then it's just a matter of typing that into a calculator. I can show you a function on the Desmos calculator that helps out when we're dealing with our fractions and you have some calculations to do. So there's this button over here with A over B, and that'll just separate up a numerator and denominator. And this is just really nice, so it organizes it. So we have 5.5 and then times 10.2. So it can really match what we wrote down on our paper, and then we're dividing by 11. So that's 5.1. And then our units, minutes. And then we could check this out if we plug it in. So let's see, if we take 5.1 divided by 5.5, we get out this decimal over here. You can see what it looks like as a fraction. That doesn't help us too much here, so either way is good. But what I want to do is compare it to if I took 10.2 divided by 11, and we see it's exactly the same. So those rates match up. Okay, the other way that is a bit shorter, that doesn't use cross multiplication. So I'm just going to kind of rewrite what we have up above there. So if you remember from solving equations that have fractions, our first step was to multiply both sides by the least common denominator. And that's really what's at work behind the scenes here with using cross multiplication. It is that idea of multiplying both sides by least common denominator. What we can do here is use the fact that Q is really at a great spot here, being in the numerator. All we need to do is get this 5.5 miles away from it. So if we're dividing by 5.5 miles, to undo that operation, what we need to do is multiply by 5.5 miles. So multiply that side, and then whatever we do to one side of the equation, we have to do to the other. So on that left-hand side, 5.5 miles divided by 5.5 miles, that will just leave us with Q equals, and then over here we'll have 10.2 times 5.5 being divided by 11. And then for units, miles cancels out, so we're left with minutes. And that ends up being the same exact thing. So this has a little less work involved. We didn't really need to calculate and then divide both sides by something. This can just be a single step problem by multiplying both sides by what's in the denominator, and that works great. So either way, if you like cross multiplication and want to just keep using that method, it'll get you to the same answer as if you kind of skip a step and just multiply both sides by the denominator. But notice that doesn't work in this case up here. When your variable is in the denominator, you need to go through that cross multiplication step in order to get that variable out of the denominator. Okay, so let's look at two word problems here and setting up proportions. So what we have here is last weekend, Cody and Clyde hiked 5 miles in the Mount Rainier National Park. So I'm just going to go ahead and highlight that we have this distance that they hiked, and that hike took 3.5 hours. So we have these two pieces that are relating to each other. We have this 5 miles and 3.5 hours. In fact, I can even write that down, that this first hike they did was 5 miles and took 3.5 hours. They're planning a similar hike. So now we're going to have this hike number 2, but the distance is changing. So we have a distance of 6.2 miles, and we want to know how long will it take. So we know the distance of 6.2 miles. What we don't know is the time. So that's where I'm going to introduce a variable, which I just go ahead and choose X each time, but you can really use any letter. In terms of choosing variables, we typically avoid using the letters E, I, and O. E and I are actually numbers in mathematics, and then O just looks too much like a 0 that errors typically come up, but you can use any letters you like there. So X hours. So what we can do is set up a rate here, and the order doesn't matter. Like, we can do this miles to hours or hours to miles. It does not matter. In fact, I'll show you the setup for both of them and you'll end up with the same solution. I'm going to go ahead and set it up so that the rates that I'm using is miles to hours. So what that means is from hike number 1, I would have 5 miles to 3.5 hours. And setting up this proportion is saying that should be exactly equal to, and then if my numerator's in miles, it needs to stay numerator of miles. So we're going to have 6.2 miles to, and then our unknown, X, which I'm going to leave the units off there. But what should happen is through our calculation is the unit should work out that we end up with hours for our units. So my variable's in the denominator, so I'm going to cross multiply. So we're going to have 5 miles times X equals, and then 3.5 hours times 6.2 miles. And then since I'm solving for X here, I just need to divide both sides by 5 miles. So I'm going to have my variable X equals, numerically, I'm taking 3.5. Let's go to the calculator here. I'm going to have this fraction with a 3.5 times 6.2, and then all of that will be over 5. And that'll give us 4.34. So numerically, we get a 4.34 out. And then for units, those miles will cancel out, so we'll just have hours left over. And that would be our answer. So if they're hiking 6.2 miles, that should take them 4.34 hours. And to do a little mental check here, what you could do is see, okay, if 5 miles took 3.5 hours, well, in terms of distance, we're just increasing a little bit. We're going 1.2 miles farther. So with that, it should just take a little bit more time too. So the idea being, like, if this came out to be 25 hours or something like that, something really extreme, it's like, well, if they're only hiking a little bit further, that wouldn't quite make sense as a solution. Also, like, if we got a negative number out, that shouldn't be happening, things like that. So just to show you, I won't go through solving the whole thing, but we could have set this up as hours to miles. So what that would have looked like is from hike number 1, we would have had 3.5 hours to 5 miles. And then that would be equal to, and then since I set time as the numerator, that means our unknown x, which should end up being in hours, would be in the numerator, over the distance, which is denominator, 6.2 miles. And then all you would do here is multiply both sides by the 6.2 miles, and you'd end up with the same exact solution there. All right, this last one here, our favorite recipe, requires 4.5 cups of rice. I'm going to go ahead and highlight that, and serves 4 people. So we have these pieces of information that connect together. So 4.5 cups to 4 people. So that works together. And then what we're looking for is how many cups. So this is going to be our unknown, are needed if we are planning a dinner for 14 people. So now we're going to have this unknown number of cups to 14 people. So again, order doesn't matter. Where you have this scenario where you have both pieces of information, we can do numerator of cups, denominator of people, or you can switch it around. You'll end up at the same answer. Something you might find is that if you like this kind of simpler scenario where your unknown is in the numerator, so you don't need to worry about cross multiplying, you can design it that way. So we could set it up so, okay, I want x to be in the numerator, that's in cups, so I'm going to do cups over people so that I set it up in a way that my variable's in the numerator. But again, either way works. So we have 4.5 cups to 4 people equals x to 14 people. Now in this case, all I need to do is get that 14 people away from x. So what I would do is multiply both sides by 14 people. So numerically, I have 14 times 4.5 divided by 4, and that should give us 15.75. Over here, that 14 people all cancels out, so we just get x all alone. And then for units, people will cancel out, so we're just left with cups of rice. And again, we can see if that makes sense. Oops, that closed down. Sorry about that. Let's see if we can get back to where we were. Okay, there we go. Sorry about that little technical error. 15.75 cups. So you can see if this makes sense. Like if we're bumping up from 4 people to 14 from 4 people to 14 people, we really have a lot more people. It's almost triple to quadruple. So that same rate should apply to the cups of rice that we're using. So that looks like, yeah, it's almost triple or quadruple that number there. So that lines up. So you can do that little mental check to see if it makes sense.